Have you ever pondered about the life cycle of stars in our vast universe? From time immemorial, humans have looked up to the starry sky with a sense of awe and wonder. The twinkling lights in the infinite darkness have ignited our curiosity, our imagination, and our quest for understanding the cosmos. What are these brilliant specks of light? How do they come into being? And what happens when they cease to exist? This unquenchable curiosity has spurred us to explore the universe's mysteries, to venture beyond our earthly confines, and to probe the depths of the cosmos. And one of the most fascinating phenomena we've discovered in our cosmic journey is the life cycle of a star. Think of a star's life as an epic tale, a grand saga that unfolds over millions to billions of years. It's a story of birth, growth, change, and ultimately, death. But unlike any earthly tale, a star's story doesn't end quietly. Instead, it culminates in a spectacular explosion, a cosmic spectacle we call a supernova. A supernova is not just an extraordinary celestial event, it's a crucial part of the cosmic cycle of life and death. Through these colossal explosions, stars scatter their enriched guts across the universe, sowing the seeds for new stars, new planets, and maybe even new life. Our journey today, dear listener, is to trace this cosmic tale, to follow the path of a star from its birth to its explosive death. We'll delve into the intricate processes that govern a star's life, the cosmic forces at play, and the breathtaking spectacle of a supernova. So, buckle up as we embark on this celestial journey, a voyage across time and space through the life and death of stars. Let's set our sights beyond our blue planet, past our solar system, and into the heart of the cosmos. In the next few minutes, we'll journey through the cosmos to unravel the mysteries of a star's life and its explosive end, the supernova. It all starts in the silent darkness of a nebula, a vast cloud of gas and dust. This nebula isn't just an ordinary cloud, but rather a cosmic nursery where stars are born. It's a place where elements like hydrogen and helium, the building blocks of stars, are abundant. Imagine a nebula as a colossal celestial soup, simmering with potential. Over time, pockets within this nebula begin to collapse under their own gravity. This gravitational collapse causes these pockets to condense, growing denser and hotter, eventually forming what we call a protostar. This protostar is like a star in its infancy, a celestial toddler, if you will, not yet capable of the nuclear fusion that powers mature stars. It continues to accumulate mass from the surrounding nebula, growing larger and hotter. As it grows, the pressure and temperature at the protostar's core also increase. This is where the magic happens. When the core temperature of the protostar reaches a staggering 10 million degrees, a process known as nuclear fusion begins. In this process, hydrogen atoms in the star's core collide and fuse together to form helium. This fusion releases an enormous amount of energy, causing the protostar to shine brightly, marking the birth of a new star. This birth is not a quiet event, but a radiant, brilliant spectacle, a cosmic fireworks display. The energy generated by nuclear fusion creates a pressure that pushes outward against the force of gravity. It's a delicate balance, but one that the star maintains throughout its life. Once the star begins to shine, it enters a long period of stability known as the main sequence. This is the star's adulthood, a phase where it shines brightly, burning hydrogen into helium in its core. A star can remain in this stable state for billions of years, a beacon of light in the vast expanse of the universe. But like all things in life, this too must end. But that's a story for another scene. After birth, a star spends most of its life in the main sequence. This phase of a star's life is much like the prime of human life, a period of stability and activity. The main sequence stage is where the magic of stellar alchemy occurs. The core of a star is a veritable furnace, a place of extreme heat and pressure where hydrogen atoms are fused to form helium. This process is known as nuclear fusion, and it's the heart of a star's life. The energy generated from this fusion is so immense that it's what makes a star shine as brilliantly as it does. Now, how long a star remains in this main sequence phase depends largely on its mass. A star's mass determines its lifespan and its brightness. The larger the star, the brighter it shines. But there's a catch. Larger stars burn through their hydrogen fuel much faster than their smaller counterparts. They live fast and die young, at least on a cosmic timescale. For example, a star with a mass 10 times that of our Sun would shine about 1,000 times brighter, but it would only stay in the main sequence for a few million years. On the other hand, a star half the mass of our Sun would shine less brightly, but could remain in the main sequence for tens of billions of years. So a star's midlife is a delicate balance of burning bright, but not burning out. It's a juggling act between energy production and fuel consumption, and the star's mass is the ringmaster of this cosmic circus. But nothing lasts forever, not even the seemingly endless supply of hydrogen fuel in a star's core. As the star exhausts its hydrogen fuel, it begins to evolve, leading to the final stages of its life. This is when things get really interesting as the star prepares for its grand finale, the explosive end. But that's a story for another time. For now, let's marvel at the beauty and complexity of a star's midlife. As a star exhausts its nuclear fuel, it undergoes dramatic changes. The burning heart of a star, its core, is a hotbed of nuclear fusion. Here, hydrogen atoms are squeezed together under immense pressure, forming helium. This process is the lifeblood of a star, providing the energy it needs to shine brightly in the cosmos. However, like any fuel source, the hydrogen within a star's core isn't infinite. As time marches on, the star burns through its hydrogen reserves. When this happens, the star begins to experience a midlife crisis of cosmic proportions. The core, depleted of hydrogen, starts to contract under its own gravity. Meanwhile, the outer layers of the star, still rich in hydrogen, begin to expand. Our once average-sized star swells into a behemoth known as a red giant, or, if it's particularly massive, a red supergiant. But the core isn't finished yet. As it contracts, temperatures rise, reaching a blistering point where helium can be fused into heavier elements like carbon and oxygen. This fusion of heavier elements generates even more heat, causing the outer layers of the star to expand further. This is where things get a bit unstable. The intense heat from the core pushes the outer layers of the star outward, causing it to pulsate. These pulsations are nothing less than the death throes of a star, the cosmic equivalent of a heart beating in its chest. As the star continues to pulse, it sheds its outer layers into space. This material, rich in heavier elements, will go on to form the building blocks of new stars, planets, and possibly even life. But back to our dying star. As it sheds its outer layers, the core is left bare. This core, now mostly composed of carbon and oxygen, is highly unstable. It can't sustain fusion without the pressure from the star's outer layers, and so it begins to collapse under its own gravity. This phase of a star's life is unstable and short-lived, setting the stage for a catastrophic finale. As we'll see, the death of a star is not a quiet affair. It's a cosmic spectacle that lights up the universe, reminding us of the fleeting beauty of stellar existence. The final act of a star's life is a spectacular explosion known as a supernova. A supernova is not merely an end, but a grand finale that briefly outshines an entire galaxy. Imagine, if you will, the sheer brilliance and power of that moment. It's a cosmic event of such magnitude, it's unfathomable to the human mind. Now, let's delve into the mechanics of this breathtaking phenomenon. The explosion of a star in a supernova is the result of a complex process that begins when the star exhausts its nuclear fuel. The core of the star collapses under its own gravity, causing a shockwave that propels the outer layers of the star out into space. It's a fiery, cataclysmic event that lights up the cosmos like a celestial fireworks display. But what happens after the dust settles, so to speak? What remains of the star post-explosion? Well, the dramatic aftermath leaves behind a dense core, which, depending on its mass, can become either a neutron star or a black hole. A neutron star is a compact celestial object, composed almost entirely of neutrons, while a black hole is a region of spacetime where gravity is so strong, nothing can escape from it. But the story doesn't end there. The supernova explosion also disperses the star's outer layers into the interstellar medium, enriching it with elements produced during the star's lifetime and in the explosion itself. This enriched material becomes the building blocks for new stars, planets, and potentially life itself. This cycle of stellar evolution, birth, life, death, and rebirth, is an elegant dance choreographed by the laws of physics. It's a cosmic ballet that unfolds over billions of years, where each star in its death sows the seeds for the birth of new celestial bodies. In its death, a star gives life to new stars, planets, and possibly even life forms, truly embodying the phrase, "We are all made of star stuff." As we look up at the night sky, we are reminded that the very atoms that make up our bodies were once part of a star that exploded in a brilliant supernova. We are indeed children of the stars. The life of a star, from its birth in a nebula to its explosive end as a supernova, is a captivating tale of cosmic evolution. It's a journey of transformation, where stars burn bright, age, and eventually explode in supernovae, scattering heavy elements across the cosmos. These elements are the building blocks of new stars, planets, and even life itself. So, the next time you gaze up at the night sky, remember, every star has a story, a life, and a dramatic end waiting to unfold.